Okay, I have a little bit of free time this evening. I kind of got to thinking about some of my students who are still struggling with math standard 6 number systems C7, which deals with understanding, ordering, and absolute value of rational numbers. So I thought I'd do a little tutorial video, and hopefully if there are some students who can get some benefit out of it, then very good, very good. So what I want to start out with is to introduce what we see here on my screen. This is a web page of free math manipulatives that are created by McGraw-Hill, Glencoe.com. So this is a pretty good video for teachers who have not used these online manipulatives, because it will be pretty beneficial in the classroom. Now, one of the things I want to talk about is under 6th grade manipulatives, we have all kinds of things. We have all of these. We also have all of these, and these, and these, and it goes on. I'm going to focus on the number line for right now, and I'm just going to drag it over here, and I want to drag it over to where we can see a little bit better, and make it a little bit bigger if at all possible. Now, the reason I am using this number line, which is the tool out of our math kit, which will be one of the math practices, is I want to explain what absolute value is. Some of my students have really been struggling to understand what absolute value is. And pretty much what absolute value means is how far away a number is from zero. So when we say absolute value, it does not matter if that number is positive, like the numbers that are to the right of zero, or if they are negative to the left of zero, because when you're dealing with distance, negative doesn't come into play. If you walk backwards 10 miles, you have gone 10 miles. If you walk forward 10 miles, you've walked forward 10 miles. But just to kind of help explain what that means, let's say that we've got a situation where we need to know the absolute value of 4. Well, with the absolute value of 4, and we'll say this here, we'll identify this as -4. We just want to know how far away is it from 0. So let's count that in jumps. We have 1, 2, 3, 4 jumps away from 0. So the absolute value of -4 is going to be equal to 4. And it does not matter that it was negative on the inside. It's 4 jumps or 4 spaces away from 0. Now let's look at another situation. Let's say that we have the absolute value of positive 5. Absolute value of positive 5. What's that going to be equal to? Well, let's say that 5 is right here. We'll locate it there, and we'll see how many jumps that we'll have to go through to get to back to 0. So we'll have 1, 2, 3, 4, 5. So we had to have 5 jumps to get back to 0. So the absolute value of 5 is 5. Now, now that you kind of see and understand why what absolute value is, one of the things I will point out is, regardless of the sign inside the absolute value brackets, the value of the number will be a positive form of that number. So I could have absolute value of -1,000, and it's going to be 1,000 because it's 1,000 jumps away from 0. I could have the absolute value of positive 1 million, and its value will be 1 million because it's 1 million jumps from 0. So I just wanted to talk about that for a second. Now let's discuss what it means when we say opposite numbers, opposite integers. Let's go ahead and talk about that. So let me pull my number line. I'm going to use the hand tool to do that. So I'll pull my number line here, and I can make it bigger. And if I want to, I can really build this number line and make it a lot bigger. Like for instance, the maximum, I can make it more than 5. Of course, then I would have a scroll bar to go to that point, and I can make the minimum less than -5. But for this demonstration, I'll just keep it with a relatively short number line. Now, let's talk about opposites. An opposite is going to be, well, let me move this out of the way. An opposite integer is going to be a number that is the same number of jumps away from 0 on the opposite side of the number line. So here we have -2, and it is 2 jumps away from 0. So the opposite of that number will be 2 jumps away from 0. 2. And here we see it +2. Another way of looking at it is if your number, your original value, is -2, the opposite will be +2. Let's go ahead and look at another one. Let's say that we've got the absolute value of -4. I just know that +4 is the opposite of that. And to prove it, you could say, well, the absolute value of -4, it is 1, 2, 3, 4 places away from 0. And +4 is also 1, 2, 3, 4 places away from 0. So if you have to deal with opposite numbers, opposite integers, if the number that you are supplied with is negative, such as -100, then the opposite of that is going to be +100. There, I made it as the 1,000. That was a little typo, we'll say. And notice I don't have to put a plus sign to make sure this is positive. It's understood that it's positive. But I can put a positive sign there if it makes it more friendly for people who are just learning what opposite integers means. Now, let's talk about how we can order absolute integers that include absolute values. So let me go ahead and clear my board. And let's change the color of my ink to pretty blue. We'll change it to blue, and let's make the ink just a little bit smaller. I don't like to have it that big, so you can make it smaller if you want. So if I have some numbers and I want to order them, let's say that I have the absolute value of -5, and then I have the absolute value of -2, and then I have just 3, and then just 4. If I were to present this to my students and I were to ask them what relationship do they see, I would hope that they would say that the integers are listed without really any relationship. I mean, for a second there, before I realized I had a 4 there, I was thinking it looks like it's gone from greatest to least. And the reason I say is because we have absolute values, but it looks like it's just a jumble of numbers here. So if I wanted to make these from greatest to least, what I would do is I would say definitely the absolute value of -5 is the greatest value here because it is equal to 5. I would say that the absolute value of 2 is going to give me 2. And then 3 and 4, those values are obvious. So the greatest value here, when I look at these, well, that 5, well, I would say negative, absolute value of -5. And then I would say 4. And then I would say 3. And then I would say the absolute value of -2. So here I have listed these values in order from greatest to least, kind of like a little countdown. Now, I know some kids, they see these negative signs and it makes them panic. They think the negative sign means that this is much farther to the left of 0 than 4 or 3 or -2. But because of these absolute value brackets, I don't even see the negative sign. I see this as, well, it's worth 5. And I see this as being worth 2. Let's go ahead and put up another one. Let's say that we have a couple other values. I'll change the color of the ink just up here. So let's say that we've got, let's say absolute value of 6. Let's say absolute value of -8. Let's say 7, absolute value of 7. And let's say absolute value of 5. Now, if I had to order these from least to greatest, because of the absolute value brackets that we have here, I consider all of these integers that we have here as how far away they are from 0, what their actual value would be. So I recognize that this is 5, and this is going to be 7, and even though it says -8, because it's the absolute value of -8, that's going to be 8, and the absolute value of 6 will be 6. And then if I were to list these from least to greatest, I could then go ahead and say that 5 would be my least, and then I would say 6, and then I would say 7, and then finally I would say 8. So here they are from least to greatest, but I'm going to go ahead and put back those absolute value brackets because that's what we started out with, and they are, and they were equal to the positives integers that I had up here already. Okay, so I see that my slate has died out on me. The battery power is shot. So the rest of these examples I'm going to be doing, I'm going to have to use a mouse. And sometimes that's okay. Sometimes it doesn't want to write very pretty. Here you can see I was using my mouse and it doesn't look very pretty. Let's go ahead and clear this. Now I'm going to put a few values up here, and let's see if we can figure out how these could look as an inequality. Now, inequality, that's just where you say one value is greater than or less than another. So here I have absolute value of -3, and then I'm going to put over here absolute value of 3, and then I'm going to have the absolute value of -5, and then I'm going to have the absolute value of 3 over here. And then I'm going to have absolute value of -17. I'm going to have compare that with absolute value of just 18. And then I'm going to have the absolute value of -4 and 4. Okay, take for a moment and look at these and think to yourself, are they greater than, less than, or equal to? Take a second to do that. You can pause the video at this point if you like. Okay, if you chose to pause it, good. If not, well, let's move on anyhow. So the absolute value of 3 is going to be 3. I know that's 3 jumps away from 0. So the absolute value of -3 is 3. And here we have the absolute value of 3, which is also 3. So in this situation, we have equal values. Here I have the absolute value of -5, and I have absolute value of 3. The value of the absolute value of -5 is 5 because it's 5 jumps away from 0. Absolute value of 3, once again, is 3. So it looks like the absolute value of -5 is going to be greater than the absolute value of 3. Here we have absolute value of -17. Now, this is just going to be 17, and here this is absolute value of 18. So positive or negative, 18 is greater than absolute value of 17. And then here we have a situation just like the top one. Absolute value of -4 is 4, so 4 is equal to absolute value of 4 here. So that's an example that to show you how you could look at absolute values of numbers and how it works with inequalities. Now I'm going to go ahead and clear this out, and I'm going to go back to my manipulatives. And this time I want to use a thermometer. So I'm going to put my thermometer over here, and I haven't used the thermometer as much as I have some of the other manipulatives here, but I really don't know if I can pull it up this way to show that it gets hotter, bring it down this way, and it gets kind of colder. Now I'm going to pull this up and have it flush with 0 degrees. Now, if we have a situation like this, In the real world, you have absolute values quite a bit with thermometers. You have positive, negative integers with thermometers. And when we say absolute values, we're talking about how far away is the temperature from zero. For instance, if I were to say, what is the temperature 5 degrees below zero? And I'm going to put it right here. Here I have negative 10, and here I have 0. So 5 degrees below 0 will be halfway between there. And so there we go. And so 5 degrees below 0, even though I say 5 degrees, it sounds like a positive integer because that's just the absolute value of negative 5. So if I have 5 degrees below 0, we have negative 5 degrees Fahrenheit. And if we were to say how far away is negative 30 degrees Fahrenheit, how far away from 0 is negative 30 degrees Fahrenheit, we can say that it is 30 degrees away. It's 30 degrees below 0. And I remember reading stories about how cold it gets there, and I can't imagine. But anyhow, that's just an example of how in the real world you'll sometimes see positive, negative numbers with thermometers. And also kind of goes along with absolute value, because you can say, how many degrees away from 0 is a temperature. So I just thought I would share that with you. And it is kind of neat how you can use this thermometer to show that. Okay, now I hope that this video has helped my students. And we'll see how they do when we reassess their ability to understand ordering and absolute value of rational numbers. Thanks for watching.